Welcome. In this video, let's talk about Hamming code. What is the Hamming code? Hamming code was invented by Richard Hamming in 1950 at the Bell Labs. The definition of the Hamming code in the Wikipedia says, Hamming codes are a family of linear error correcting codes. Hamming codes can detect 1-bit and 2-bit errors or correct 1-bit errors without detection of n-corrected errors. Okay, this is the Professor Richard Hamming. Before we jump into the Hamming code, first let's look at the parity bit. The parity bit is to detect data errors. A single bit error is detected by the parity bits. Two types of the parity. One is even bit, another is odd bit. Here has two examples. For example, the data bits 0100, the number of the ones bit is 1. Here has only one bit is set to 1. The parity bit sent to 1 so that the total number of the ones is even number. Here has the chart. For the even parity, this is data and only have the 1 bit for the 1. So we put a 1 in the parity bit, so make it even. Another example here has data 1100. So here it already has 2 bits, and then make it even parity. We set this parity bits as 0, so it is even. Always make total number of the 1 bits as even. So here has 2, here has 1 plus this one is 2, that is even. As the same thing, it's a odd parity. If the data has only 1, so we put 0 as a parity bit to make it still in the odd. This example, 2 1-bit in the data, and then we set a 1-bit in the parity, is made total 3 bits as odd. Okay, this is a parity bit. Let's take example, the parity bit position in the Hamming code. How to insert the parity bit. And basically, if we have m bits of data and to be stored in the memory, we need key bits of the parity bit to calculate and save with this data in together. And the total length is going to data bits plus parity bits. And then save this in somewhere. And then after we read it out, we are going to compare the data bit and the parity bit, make the calculation to compare before saved, after saved to read it out, is any difference. If something different, that means the error was happened. Okay, where this parity bit to be saved is going to follow the 2 powers n. N's can be 1, 2, 3, 4, 5, 6, 7, 8. This is bit position 1, 2, 3 to 12. And this is binary position number 1, 2, 3, 4, 5, 6. The same thing. This is just a binary. And then how to find where we use the parity bit based on this formula. Power 2 powers n, 1 the n equal to 0. So that is 1. So we are going to put the parity bit in the 1 of the position 1. And if n equal to 1, 2 powers 1 is equal to 2. This is the 2. Number of the 2 position is going to be the parity bit. Then the n equal to 2, going to 2 powers 2 is going to be 4. So the fourth position going to be the parity bit. At the same thing, if n equal to 3, 2 power 3 is 8, and the bit 8 position going to be parity bit. And the rest of the bit position going to be data. So position 3 is data 1, position 5, data 2, 6, data 3, 7, data 4, 9, and data 5, and so on. This is total. You see, total 8 bit of data plus 4 bit of parity. That's going to be used 12 bits. So this is m plus k equal to 12, and then we have 8 bit of data and 4 bit of parity. Okay, calculation of the parity bit. Each parity bit operates on every data bit whose position number contains a 1 in the same bit position as the position number of that parity bit. Okay, how do I understand this one? For example, we have the parity bit 1 here. This is parity bit 1. How this parity bit calculate? We are going to use his position number has a 1 in the least significant position has 1, and then we are going to find any database least position has 1. We are going to calculate that bit. Okay, so the data bit 1 in the position 3 here has a 1 in the least significant bit position has 1, so we are going to calculate this data bit 1. Data bit 4 here you see the 0, and that is parity, skip that one. Data bit position 5, the least significant bit is 1. We are going to use this data 1. And 6, this significant position is 0, skip this one. And the 7, the least significant bit is 1, so we are going to calculate data 4. Same thing here, 0, we skip this one. Here has a 1, so we keep the data 5. Position 10, that is data 6, has 1, so we skip this one. We are going to calculate data 7. So parity bit 1 going to calculate data 1, 2, 4, 5, 7. And parity bit 2, his position number 2 has 1. So we are going to keep all the data. Second bit has a 1. Second position bit has 1. So we are going to keep the second bit position 1, that is data 1. Okay, data 1 has least significant 1, and the second position also 1. So the parity bit going to also calculate data 1. But the data 2 second position is 0, so skip this one. The data 3 has second position is 1, that is 6, keep this one. 7 has 1, keep this one. Here 5 is 0, so we skip this one. Position 10, data 6 has 1, so we keep this one. So parity bit 2 going to calculate data 1, data 3, data 4, data 6, data 7. Data 7 bit. Okay. And same thing here, position 4, parity bit 4. Parity bit 4, his position number has third position, it has a 1. So we are going to keep all third position 1. So 5 has third position 1, 6 has third position 1, 7 has third position 1, and skip all the here third position zeros. We keep that bit 8 has 1. So fourth parity is going to calculate data bit position 2, 3, 4, 8. And 8 is here, his fourth position. His fourth position is 1. So we keep all the 5, 6, 7, 8. Okay, so that means parity bit 8 going to calculate all these four positions data bit. Okay, what exactly, how to calculate? It's going to calculate exclusive OR of this data bit. So parity bit is going to calculate data 1, 2, 4, 5, 7. So 1, 2, 4, 5, 7. Every bit exclusive OR to get either 1 or 0. And then this bit going to be right of 1 or 0. Example here, parity bit 8 going to calculate data bit 5, 6, 7, 8. 5, 6, 7, 8 to calculate or exclusive OR to get either 0 or 1, and then to save into the parity bits at here. Okay, that is a Hamming code. How do you find the parity bit location and how to find which database was calculated by the parity bit. And also the function is just a simple exclusive OR. Okay, thank you very much. See you next time.